Okay, so the last thing in this section is to move the center of the convergence to another place. This is optional, so it's interesting. So if you can understand this. So what's the reason? So why do we want to do this? So first, let me explain what we are trying to do. So we know that a power series is of this form and is centered at x equals a, and the center of the interval of convergence is also a, which means around a, in the neighborhood of a, you will get convergence for this series. But sometimes we want to move the center of convergence to another point x equals b. So if we want to do that, is there a neat way of doing it? Now, obviously, there is one way is to find a new power series from scratch, but sometimes you can do it in this manner. So first, the question is why? Why do we want to do this? So let's use this only. Suppose I have a function like this. Now, obviously, one would not use power series to approximate this. So, because this is such a simple function. So, suppose we want to find f of, now the power series for this we know very well is x to the power k, k going from 0 to infinity. So we know this. So now if I want to find f of 0.5, then all that I have to do is use this, and with 0.5 to the power k, and I can add up large number of them and get the value of function at 0.5. It would be pretty good because my interval of convergence is -1 to 1. That means I can use it because x is 0.5. However, if I want to find, suppose, f of 2.5, then I cannot use. Then that power series is useless because the interval of convergence is -1 to 1, so x has to be in that interval. So if I do have to find this, I should move the center near 2.5. So if I want to do that, I should go somewhere near 2.5. So that's the reason why we should be able to do it. Okay, so let's do this example. So we want to find the power series of 1 over 1 minus x. Now the center of this series is 0, we know that. And we also know that the power series of 1 over 1 minus x is x raised to the power k, k going from 0 to infinity. So what we want to do is we want to move the center to a equals 2. So here is the trick. So it's algebra basically. So I have 1 over 1 minus x. Now what I'm going to do is, because I want the center to be 2, I want x minus 2 in this expression. So I can do that by writing 1 minus, now instead of having x, now if I have x, clearly x is x minus 0. That's why I was having the center as 0 for this one. But I want x minus 2. So I'd say, okay, fine, I'm going to write x minus 2. But when I do x minus 2, actually what I've done is I have added 2, because look, 1 minus x plus 2. So since I added 2, I have to subtract 2 right away. Okay, so now what is this? 1 over, now I want x minus 2, but then I have 1 minus 2. So that means negative 1 minus x minus 2. But to be able to use, remember, I have to use this series. 1 over 1 minus x is summation x to the power k. So I have to have this number doesn't matter because this is just in the numerator, so I can always take care of it. This must be 1 and minus something, whatever this thing is goes here as x. So I have to have a 1 and a minus. Okay, so I have a negative 1. So I factor out negative 1 and then I get 1 plus x minus 2. So that means negative 1 over 1 plus x minus 2. Now remember, these are all equal. So actually I started from here and these are all equal statements. So this is almost there. I just don't want this plus. I want it to be negative like this. So what I'm going to do is negative 1 over 1 minus x plus 2. Now it's in the perfect form of this. So it looks exactly like this. So negative 1 is not a problem, that I can keep here. And then I have summation. Now when you have x, you have x to the power k. Now here I have minus x plus 2. So this is going to go raised to the power k. So this becomes minus 1, k going from 0 to infinity, minus 1 to the power k, so it's alternating, times x plus 2 raised to the power k. And there's a minus 1 here. So if I take this inside, I get k equals 0 to infinity, negative 1 to the power k plus 1 times x plus 2 raised to the power k. So this is centered. I just copied this wrong. 1 second. This was x minus 2. So this is x minus 2. This is minus. This is minus. So x minus 2, this is minus x minus 2. So therefore 1 over 1 minus x is equal to this power series and this power series is centered at a equals 2. So now let's try centering it at a equals -5. Okay, so let me remind you again. 1 over 1 minus x is summation x to the power k going from 0 to infinity. Now if you want center at -5, so if we want we must have x minus a. So what is that? X minus a is -5. So that means I must have x plus 5 in the expression. So I am looking for x plus 5. So let's start. 1 over 1 minus x is equal to 1 over 1 minus, now I want x plus 5, so let's write x plus 5. But to do that, I essentially got 1 minus x minus 5. So I subtracted 5 to get this. So I must add 5. Please notice that this is equal to this. Okay, it's just algebraic manipulations. Okay, so this is 1 over 6 minus x plus 5. 1 plus 5 is 6. So that's okay. Now remember, to be able to use this result, this number doesn't matter, but this is most important. It must be 1 minus x. Right now I have 6 minus this. So how do I get rid of 6? I can factor out 6. So if I factor out 6, I'm left with 1 minus x plus 5 over 6. So that means this is 1/6. This 6 can come up like this, or actually doesn't really matter. It can be written as 1/6 like this. 1 over 1 minus x plus 5 over 6. So now look at the similarity between this and 1 over 1 minus x is summation x to the power k. So when I have x, it goes to x to the power k. Now I have this. So that means 1/6 summation x to the power k. But instead of x, now I have this. So I would say x plus 5 over 6 raised to the power k. K going from 0 to infinity. So this is same as saying summation. Now 6 comes in, so every term gets 1/6, and there is 6 in the denominator. So I have 1 over 6 raised to the power k plus 1 times x plus 5 raised to the power k. So that means 1 over 1 minus x can be written like this, and this is centered at a equals -5. That's what we wanted. So this is a nice way of generating power series at different centers. So this concludes our chapter 11.